Hello ladies and gentlemen, so today we're going to look at chapter 6, which is on solving systems of equations. The first section is on how to solve a system of equations using graphing. What you're going to want to have on you, notes, a pen or a pencil, and you will probably not need a calculator today. So this video is going to focus on how to solve systems of equations using graphing. So we're going to take a look first on remembering how to graph. So you should remember how to graph a linear equation. You're always going to start at your y-intercept, which is the number alone. So this is your y-intercept right here. You're going to start at 5. Put a dot there. There we go. And I'm going to use my slope, which is 2. Now, remember, slope is rise over run. So 2 over 1. So up 2, 1, 2, over 1, put a dot. Up 2 over 1, put a dot. Down 2 over 1, put a dot. Down 2 over 1. Just kind of make myself a nice little line right here. It's going to be something like that. And I want to connect my dots. It's a pretty good line. So that's how you graph a line. So now you're going to use that same thing on solving systems of equations. So we have two lines to graph. Y equals 3/2 x plus 1 and y equals -1/2 x minus 7. So what I recommend is graph them in two different colors. That way you'll see what you're doing. So I'm going to graph this first one in red. So I'm going to have centered at +1 for my y-intercept. And then up 3, 1, 2, 3 over 2. Up 3 over 2, 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Down 3, 1, 2, 3. Oops, 1, 2, 3, 1, 2. Another one right there. Another one right there. So I'm going to connect my dots here. Something like that. Now I'm going to go over here. I'm going to change my pen color. I'm going to change it to this pretty blue. Now I'm going to graph this new line. -1/2 x minus 7. So I'm going to stay at -7, start there, and go down 1 over 2 each time. Should have a negative slope this time, which I notice I am getting. 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, right there. Connect my dots. Whoa, that was really, really bad. But I noticed that my two dots connected right here, right? Right on that point. Which if I find that as an ordered pair, that is -1, 2, 3, -4. What's my x value, or my y value? -5. So I know that this is my solution to this system. So I know that ordered pair should work in both of them. Now, what I'm going to do is I'm going to go into the check phase. We're always going to do a check once we get our answer on any time we solve a system. So this is my x and this is my y. So let's plug those in. So I have -5 equals 3 over 2 times -4 plus 1. See, I'm plugging x and y in for my top equation. So I have -5 equals 3/2 of -4. Well, I know that that is -6. If you need to use the calculator on that, please feel free to do so. And then I know that's plus 1 at the end. Now, -6 plus 1, I know that to be -5. That checks out. That's why I'm putting a big check mark here, just to say, hey, I know it works. So now I need to test this point in my ordered second equation here. So I have -5 equals -1/2 times -4, it's my x, minus 7. So I have -5 equals -1/2 times -4, that's a +2. I get a -5. Checks out. So they both check. So I know -4, -5 is the answer to my problem. Now, you do not need to show this work usually. If you need to just check it in your head, that's fine. However, there can be systems that you do get a solution that is not correct. And we'll look at that later in the year, later in this chapter. Alright, so let's take a look at this problem. Y equals 2x plus 1 and y equals 2x minus 1. So I'm going to first start my first one in red, just like last time. Graph my first line up 2 over 1. You should be doing the same thing on your paper. Should have a line that goes like something like that. Alright, change my color again, just like last time. This time I think I'm going to go with green. And I have to do 2x minus 1. So I'm going to go start at negative 1. Go up 2 over 1, up 2 over 1. Do that on all of them here. Then graph my line, connect my dots here. Now, this one's kind of silly. Unlike last time where we actually got a little dot in the middle where they crossed over, these two lines do not cross over. Now, that can happen. What this means, your answer for these kinds of problems where your two lines do not cross, this is a no solution problem. Now, the reason behind that, they don't intersect. And how do you know if they don't intersect? What if you just want to even know, before even graphing, it's a no solution? If you have the same slope, you have parallel lines, right? I have the same slope here. Parallel lines means no intersection. So if you solve two equations and you notice that they have the same slope, you know for a fact they have no solution. Let's take a look at this last one here. So 6x plus 2y equals 4 and 3x plus y equals 2. Now, you technically cannot graph these right away. You can use the x and y intercept, or you need to actually solve these. So on these ones, top one here, I'm actually going to solve that for y, so that way I can graph it. So I'm going to subtract 6x from both sides, just like normally we would do. And I'm going to get 2y equals negative 6x plus 4. Need y alone, so I'm going to divide by 2. Alright, graph that line. So I have positive 2, down 3, 1, 2, 3 over 1. Down 3 over 1, down 3 over 1, down 3 over 1, 1, 2, 3, 1, 1, 2, 3, 1. Okay, so it's going to be something like, whoop, that's a really bad line. There we go. Something like that, right? Now, change my color so I can go to the other side. That way, this allows me to know what color is for what work. So this is my blue colored work. And my blue colored line, solve for y just like last time. Subtract 3x, we get y equals negative 3x plus 2. So I'm going to start at 2, go down 3, 1, 2, 3 over 1. Down 3, 1, 2, 3 over 1. Down 3, 1, 2, 3 over 1. This is kind of odd that this keeps doing this. 1, 2, 3 over 1. 1, 2, 3 over 1. So it looks like I get the exact same line. Which makes sense, right? I have the exact same equation. You probably noticed that even before we started graphing. Now, when this happens, you're going to name this as infinitely many solutions. That means the same line has been graphed twice. Best way to know, even before graphing, same equation means you're going to have infinitely many solutions. But be very careful. Make sure that you always solve correctly if you need to solve. Otherwise, you can have mistakes. A negative can make a big difference. That's the end of the video. See you later, Sabers.